I'm your host, Mike Schwartz, founder of Glue. Today is episode 183. And before we get started, just a quick reminder to follow Identity Office Hours on LinkedIn. We're 40 followers shy of 2,000. Our topic today is bots with keys. Welcome to AAuth. Our guest today, as most of you can see, is Dick Hart. Welcome, Dick.
Thanks.
And Rohit Kari might be joining us. I think he's looking for parking. So if he joins later, we'll just add him in. But we're just going to dive into it. Dick, we're going to skip your intro because you were a guest a long time ago on one of the first episodes, episode 5. You were also on episode 99. So this is your third appearance. And so the topic today, bots with keys. Welcome to AAuth. This is a number of specs that you've been drafting, I think, with Christian Posta and maybe others too. And maybe, we can we sort of just dive into it and ask, I just want to dive right into it and say, in an AAuth flow, the agent requests a mission. And I wanted to start with this question: what's a mission, and how does that maybe the mission sort of show like how things have changed a little bit?
Sure. Well, in AAuth, we've iterated a bunch. So Christian's given a huge amount of feedback about, like, he's implemented it, and I've changed the spec, and then he's like updated his code again. And Carl McGinnis has also been providing a huge amount of feedback. And I find it interesting in some ways that AAuth, I use Claude heavily in writing the spec and in iterating and in tuning up things and having it review the spec. And so it's one of those specs that's probably one of the first ones that's sort of about agents, that's also heavily written by agents. And that every time I would have a new draft, I would go and share it with Christian and Carl, who would feed it to their agents in their world. And then their agents would give a bunch of critique and feedback, and they would send that back to me, that I would then feed back into my agent to say, oh, what about this criticism? Should we do something different? And so, in many ways, it's interesting that it was really partly a bunch of different agents with different contexts and a few people evolving the spec. And in the latest ones, we have a few different levels. So the most powerful set of features includes missions, as you talked about. But you don't need to have a mission using AAuth. And in fact, you can use AAuth without using any centralized service of just a client talking to a resource, or an agent in AAuth terms, talking to some resource. But the mission was one of the things that Carl brought up about, we needed some way of managing the context across a whole bunch of authorizations, right? And so in OAuth, right, you get one flow and you say, is this okay? But then later on, there's another authorization, and it's like, oh, okay, well, what does that have to do with anything else, right? Each of those is separated in the little silo. The mission enables you to sort of pull this all together. And part of the motivation for that, and the reason you need that, is because, software has changed, right? When you're using an agent, it may be running over hours, maybe even days. You forgot the context you sent it on, perhaps, right? And unlike traditional software, where generally you know ahead of time what you're trying to do, and so in OAuth, it's like, okay, I need to go get these scopes, and then I can go and work, right? Here's everything I might need, and I can go get it ahead of time as a piece of software. In the agent world, it's more like, oh, I want you to go do a mission. You figure out how to do it. You figure out what things you need to call, what permissions you're going to need. It's going to be dependent on what you discover the agent needs to figure out to do it. And so you then move into this model where you need to do authorization along the way. And anyone that's been writing code with Claude, right, every once in a while it says, hey, can I do this? Hey, can I go and do this? Right? 5, 10, 15 minutes into it. And so that mission enables you to have the context of, why is it asking? What was it trying to do? And is this thing make sense in the context of the mission? So Carl had written up a number of documents around talking about the mission, and then I added mission into a sort of this overarching theme in AAuth.
And this mission is written in English, right?
Mm-hmm. Well, more specifically in Markdown, but yes, it's prose and how agents are parsing, and what's efficient way for them to pull stuff in as tokens, and what's an efficient way for them to display information back to us.
Right. And so I'm an agent on a mission, and I'm calling resource servers. And this part I found really interesting was like this. You mentioned that the agent had no idea what tasks it needed or what APIs it needed to do before ahead of time before it started thinking about the mission and making a plan. And so the flow almost starts with a call to the resource server, right? And that's a little different, I guess, from a typical OAuth flow, where normally you would start by getting a token and then presenting your token. But why the change?
Well, in OAuth, the typical flow in OAuth is just the software already knows ahead of time what it wants. And so the first thing it does is it sends the user over to the AS and says, here's what I want, right? Like there's a browser redirect right away. And some profiles of OAuth have, I'll go and I'll call the AS back channel before I send the user to it. In AAuth, we went in even deeper, and it's like the agent is calling the resource, and the resource generates when the resource says you need to go and get authorization for this, it generates a resource token. And that resource token captures what it is that what permissions the agent needs to be able to access and do the things it needs to do. And there's a number of features that fall out of that, is that resource token, since it's signed by the resource gives that to the agent. It has the thumbprint of the key used by the agent. And so when the agent calls in our world, we have a person server, calls a person server to get a token. It signs that, but also passes the resource token. And so now the person server knows, okay, I know this particular instance of the agent called the resource because the resource signed it. I know what the resource says that you need to have to talk to it. And it addresses sort of a number of the man in the middle and confused deputy security issues that happen in other protocols, because you have identity of the resource as part of that whole authorization decision.
I noticed you called this thing a person server, which is a term I had never heard before. Not an identity provider. But there might be some overlap there. Why did you choose to call this a person server?
Well, I iterated a bunch on what that term was. Not everybody thought it was a great term, but we don't think that there's a better term. And the reason is that the person server, right, it is an identity server for the user, but also the person. So part of it, landing on person, means it's representing the legal person.
Wait, can I just pause there for a second?
Yeah, sure.
I'm really struggling with this person word because a corporation's a person. And, after watching Murderbot, I'm not convinced that a AI couldn't be a person. It's not true yet, but I think it could be true that a piece of software could achieve personhood if you were to get to AGI. And in Murderbot's actually organic
I know the show. Yeah, I love it.
cyber construct, so he's a little bit in between. But my problem with a person server is that I think what you mean is a human server, not a person server.
No, I do mean person for that explicit reason, right?
Okay.
Who is the legal person operating this bot? And it could be an organization, right? Like it may not be associated with a specific human, right? It's a role, but there is always some legal person behind it. Bots currently, right? They're not self-aware, self-evident. It's not like we're not at Murderbot yet,
Not even
But
close.
hopefully, knock on wood on that. But it is represent a legal person. So a lot of agents are being deployed not by a specific person, right? But it's acting on behalf of the organization. And so that was part of why we went to person server, is that it represents the person operating the bot, which could be a user, could be an organization. And that person is the person server presents the identity of the person, which could be an org or user, but it's also the server that's managing the mission for the person. And so it's representing the person in the protocol.
Okay.
Just like the resources server is managing the resource, and the agent server manages agents.
And in your architecture, you look at agents as sort of a first-class identity or a first-class entity. They're not humans. They're not clients. They're this new thing called agents with their own metadata and their own keys. Is that right? And why the move in that direction?
So in AAuth, there's a concept of an agent server, which is, from a protocol point of view, passive. It just has the metadata for any of the agents working with it. And so it has a set of keys. And then each agent is actually part of that agent server, right? And so you can have a whole bunch of agents that belong to the same agent server. And so the identifier for an agent is local name at domain, right? And so then you could have a bunch of instances. And so you could even have agents, your own agents running on your own machine, and we've got sample, code that helps set this up, where I could have dickhart.github.io is my agent server, and then I could have Claude at dickhart.github.io would be my Claude agent, and I could have OpenClaw at dickhart.github.io. I could have a bunch of agents running off of my machine using keys based off of the key in my enclave on my machine. So I have a non-exportable key, right? There's no client ID, no API keys to steal. The keys are tied to my machine, but the identity is tied up into my github.io metadata page. It's just static, right? The agent server doesn't have to have anything active, dynamic running. And the idea of each agent having its own identity means that an agent can be associated with just one person. And so that then the person server knows, oh, this particular agent, right, is working on behalf of this one person that I also represent. And then that way key, or like tokens, are auth tokens that you hand out to let an agent call a resource, are bound to that specific instance, that one agent. And so unlike OAuth, and OAuth came about in a world of servers talking to servers. And so the identity was at the server layer, where in AAuth, we view that often the piece of software running is on a device somewhere else. It could be on a mobile device, can be on your own laptops, right? Or it's a workload within a larger system. It isn't, a server per se. And so you get that ability that, I didn't authorize all of Anthropic to call something. I authorized my instance of Claude to do something, right? Where in OAuth, the client ID is for the entire server and every instance underneath of it.
Spiffy is really popular these days because Spiffy provides a way to bootstrap that identifier. Because what is the right identifier for an agent? And in your solution, it seems like you're suggesting a specific schema, like agent at agent server. And it looks to me like you're leveraging Auth DNS, right? But what about those? What if I have an agent running on my phone and my phone doesn't have a DNS name? Is there some way I can hook back to agents running on sort of devices that maybe don't have a static IP address?
That's why we have those two layers, right? Like in the example I gave you, I'm running an agent on my desktop. My desktop doesn't have a DNS address, right? It's not resolvable. right? But my GitHub, my dickhart.github.io does. And so where the public keys are for binding the server name to the sort of the top level keys is in DNS land, right? So you have something on your phone and you can pick any domain you want and put your server keys on it. And then you have another set of keys that your mobile app is using to make calls. And so your agent keys are on your device. The public keys for that bound the server domain to the server are up as static files in the server.
Have to be. Okay. Now,
But
in your architecture,
in OAuth, right? Like, it's just, here's a server, right?
I think that's fair. So you're saying, okay, I'm gonna have to publish my public keys somewhere, and that somewhere is going to have to be internet accessible, or it's just not going to work.
Right. I mean, yeah, we're bootstrapping off of DNS, right?
Yeah.
And one of I gave a presentation recently at the WebBot Auth IETF working group, and I called out and I says, we've solved, if you think of HTTP with a client and a server, we've solved servers have an identity, right? DNS, TLS, Let's Encrypt have enabled us to know here's this server's identity. But we haven't solved how does the client identify itself. And so I'm building off of that server identity, and that, okay, the server can have a bunch of clients, and then one client can go and call a server and be able to prove it's a particular client over and over.
Yeah. And you felt like OAuth dynamic client registration was not really a good fit for this. And we talked about how the agent is providing its own keys and its own identifier, I guess. But maybe you could talk a little bit about why you felt that dynamic client registration wasn't a good fit, assuming we could solve the identifier piece, because the identifier piece, it was sort of solved in SAML. In SAML, a relying party had an entity ID. You could say Spiffy provides a way potentially, but what was it about? If we're having this agent server, why shouldn't the agent server maybe be an OAuth authorization server, and why shouldn't the agent entity actually be an OAuth client entity?
Well, we're mixing a few different concepts in there. So, clients in HTTP, I mean, and that's really what we're trying to do, is like, what's the identity of the client, whether we're using OAuth or something else. A lot of these things are boiled down to, how do I know what client software is calling the server using HTTP? In many enterprises, they use MTLS, but that's because they've deployed their own, public key infrastructure inside, and they have control over that. But MTLS hasn't been able to break out of the enterprise into the open web. People use dynamic client registration in an enterprise as a way of dynamically registering clients. Once again, in a tightly controlled environment, it can work. But on the open web, there's a whole other set of security concerns. And like, how do I just be some random identifier that's not a controlled namespace? Doesn't work. And so the requirements you need for an identifier on the open web are very different than an identifier in a closed environment. Spiffy works in a closed environment where you have, we all have only these parts. But in many of the things you're trying to do on the open web, you're trying to enable a client to talk to an arbitrary server that it's never seen before, right? That doesn't happen in the same way in an enterprise. And so you needed some way around, how does the client prove who it is? And the dynamic client registration was, I trust the client to go and say who they are. It's like, well, how do you know it's really that client? The SIMD spec says, like, okay, I can prove I'm a particular server with the SIMD document, but it doesn't scale down to a whole bunch of devices, like your example of your mobile phone wanting to be able to prove it's a particular instance. It's an agent. It's an instance of the agent. It isn't part of it isn't the server per se.
Yeah, and I wonder about that actually. I was actually about to pivot into the direction of SIMD. And for those of you who have never heard that pronunciation of the acronym, SIMD is CMID, or the Client Metadata Identity Document. The first time I heard SIMD was at the MCP Summit on it. So if you never heard that, you can definitely, I understand why. So SIMD says that, a piece of software can assert, I guess, an identity and other claims, and in that document could be a device attestation. Um, maybe I'm this kind of phone, or devices also have a cryptographic module where maybe they could even generate a public key and tell you that it's been generated on the device. So I could see you going pretty far with dynamic client registration, and an agent, maybe even an agent running on a mobile device saying, okay, here's my identifier, um, here's my public key that's bound to my particular piece of hardware. Here's an attestation that shows you that I'm a non-rooted phone. Um, and now I'd like to now I'd like to register and obtain a token. So what is, I guess, the delta, and why do you feel like that doesn't get you far enough?
So SIMD works on resolving a host name, right? And so your mobile device doesn't have a host name on it. So like, how are you mapping the device assertion from your mobile device to a resolvable host name?
Yeah.
Right?
I'm not an expert on this. I don't know if the identifier in SIMD has to be a URI.
No, it's a URL. I mean, SIMD is using the same .well-known mechanism that,
Mhm.
like, we're using the same primitive we're building on in AAuth, right? It's, you have a host name, you resolve down to a metadata document, and in that metadata document is a link to where the keys are. And so you're able to bind the identifier through to some metadata, right? And so in AAuth, we've got agent metadata, we have resource metadata, we have person server metadata, and we have access server, auth server. Geez, like, what's the name? Like, it's an AS. So it's metadata as well. And so that metadata, like, we're doing the same thing that OpenID Connect does, that SIMD does, which is I have an identifier and I can resolve it down to the public keys. And then that lets me know that whoever signed this and gave me that identifier, and I'm able to go and bind that and verify it with those public keys, that they are that identifier, right? So AAuth and SIMD are building on that same basis. AAuth takes that a step further and says, well, that's a server that itself generates tokens used by agents. And so there's a layer of indirection all the time in AAuth between the agent server and the agent. And so then that enables you to have many, many agents that all have the same agent server. Where SIMD, it's the server, right? There's one endpoint, one set of keys.
Okay, I want to pivot a little bit to HTTP message signing, which is something that's sort of new in our space. And I guess the idea is, at a high level, the agent, I guess, uses its private key to encrypt a payload, which goes in this in I guess an HTTP header, and sends it. And that the idea is that basically the token can't be stolen, I guess, or this it protects against the token being stolen and replayed. And maybe you can just, maybe I got that wrong a little bit, but maybe you could just talk a little bit about why you chose this particular mechanism for sending the payload about the agent, versus sending a signed JWT or something like, or using Depop, for example.
Right. So there's, the OAuth EPOP spec, but that's very specific, right? You prove possession of some other process that happened with AS that you're the one that had that access token. So it's quite limited in what I can do. Why don't we do a little review of HTTP message signing, which is there's some headers and it's signing, not encrypting. And so there's a header called that's the signature input, which says, take all of these headers in the HTTP call in this order and put them all together. And we're going to do a SHA-256 hash of that and then sign that. And then that signature is in a header that's called signature.
Mm-hmm.
But that spec didn't talk about how do you move the key, right? It said, how you get the key for whoever's signing it is an exercise. And so there's a spec I have in HTTP BIS called signature key, which is how do you pass the key as another header. And then that key, there's a number of different schemes for how you can pass the key. The one AAuth uses is that you pass a jot in the header. And so that jot, and it is a CNF claim which has the public-private key used to sign the header. And so when you get a AAuth API call, right, there are all calls, whether it's to a resource or to a person server, are all calls that are HTTP message signed, and the agent uses its key to sign, and it includes the jot it got from the agent server to prove that it's a particular agent of that agent server. And so the other side gets that jot, goes and gets the agent server's public key, verifies the jot, then it verifies the signature of the call using the keys that are in that jot. So this enables you to have ephemeral keys by the agents where it can keep rotating its keys without you having to go and publish new metadata, and lets the other side, it can cache the jot that it had, so it doesn't have to verify the jot all the time. So it enables you to rapidly go and easily sign a whole bunch of messages you're making. And then that's essentially, that jot can be either just the agent token it got, or if we move further in the protocol where the agent talked to the person server, it gets an auth token. And so it passes the auth token in the signature key header. And so instead of it being passed in an authorization header, it's up the token that says what you're allowed to do or says what the identity of the user is, which is another point we haven't hit either, which is that in AAuth, we only have an auth token, and it can have identity claims and or authorization claims. There's not like this, I have an ID token that's used for login and I have an access token that's used for authorization. They're all just one kind of token in AAuth. And so the resource can say, I want to know who it is, and I want the user to say whether it's okay for this agent to read the calendar or not. And you can have both of those in an auth token.
I was actually going to dive a little bit into the payload. And when you're calling it a token, it's really the payload of this HTTP message signing mechanism, right? It's not a token like a sign, like the signing was the HTTP message, or
no. There is an auth token that's a JWT. Yes.
Okay.
And then inside of that token is the public key matching the private key that's used to sign the HTTP message.
Okay.
And so the keys of the agent are bound to its token, and then it uses its keys in all of its calls, which lets the other side know, oh, I know for sure that you made this particular HTTP call. But it also binds the token to the whole call, so that if you lost an auth token, no other server can use it, because only that one agent can use it, because the token is bound to the key of that particular agent.
Okay.
So we
And
moved away from any bearer tokens, any shared secrets, right? All of that is gone. There's nothing like that at all in AAuth.
so is the JWT that's in the payload signed,
Mm-hmm.
and it's signed by the agent
Or signed by the person server.
or signed by the person server.
So
Okay.
if it's an auth token, it's signed by the person server. If it's an agent token, it's signed by the agent server.
And okay, so technically, if it's a JWT, we could do revocation using OAuth status lists. But have you thought about revocation, or is it not a concern because this is a very short-lived authorization call or token?
So because everything has got a crisp identity and is resolvable, we have revocation. The resource can support a revocation endpoint where the person server could just call it and revoke it. The status list was really because you had a layer of indirection and that somebody issued tokens and then somebody else can use those tokens. And so you needed some way of being able to go and say that the tokens that have been issued are gone because the thing that issued them doesn't have a way of calling where they went. Where in AAuth, the person server does know where the token's going because there's an audience. And so it can just call the resource directly and say, kill that token I gave you. And even though the person server has never directly interacted with the resource knows who's calling it because it's once again HTTP message sign. So it says, oh, this person server is calling me. Oh, and it's talking about this. It's got a JTI for a token, and oh, that JTI is from that person server, and so I know I can go and kill it. And so a whole bunch of the complexity and token revocation goes away because all of the parties have their own provable way of proving who they are, and they do that as part of making any HTTP call. And so you're not having to have some other layer that's figuring out how do I know who you are. It's a layer right on top of HTTP with HTTP message signing.
Right. And I guess that sort of brings up this point that when you do this type of signing, the token is only good for one hop. So you sort of have to have a multi-leveled architecture where one agent maybe calls another MCP server, and then that server acts like an agent and calls another server with a similar type of using the agent, the AAuth protocol also. So maybe you can talk a little bit about that. Is that in these very complex cloud ecosystems where we have lots of services calling each other, is this type of architecture actually going to scale?
So that was a core primitive we wanted to enable in AAuth was the ability to do call chaining. In fact, we have two mechanisms, but we'll focus on the call chaining. But before we dive into that specifically, we need to go back to one of your first questions about missions,
Yeah.
right? Because you're call chaining, and it's like, does this make sense in the context of a mission? And so when an agent calls a resource, if it has a mission, it passes the mission identifier and who issued the mission as one of the headers. And in the resource token, then the resource signs its token saying what the request is, but it provides that mission in the resource token. And then when the person server issues the auth token, the mission is in the auth token, right? So now the mission is embedded in to all of the tokens moving around. And so when an agent calls a resource on a mission, right, the mission's in there. And then when that resource wants itself be a mission, be an agent, well, it knows who issued the mission. And so we can call back to that same person server and say, hey, here's the upstream token that you gave somebody to call me. And here's the resource token that I would like to call downstream. And it can send all of that back up to the person server. Now, the person server, if they're effectively also the authority for that other downstream resource, now can process that and provide back a auth token back down to that intermediate agent. But in evaluating that whether it should grant that token, it's doing it in the context of the broader mission, as opposed to like, well, why would you be calling this, right? It doesn't, like, if all it knew is like some other thing is being an agent calling something, it's like, I don't know why you should do that, right? But when it's got the upstream token, the mission, and the downstream thing, it can make a decision with all the needed context. And then if the other resource is actually in a different trust domain, the person server would call over to that auth server to go and get the token for that agent to call the resource to trust this other auth server. And so that enables you both to have call chaining, but also to cross trust domains around how do I have resources here calling resources over there that have a completely different authorization server making decisions and issuing tokens.
Hmm. I noticed in the list of specs, one of the specs was about describing resources, and it actually reminded me a little bit of the UMA resource. In UMA, there's a way to describe resources also. But just in having a quick scan of it, I was a little bit like, I was wondering, some of the resources in there looked like they were conflating resources and actions. Um, and I guess having an authorization sort of like framework in my head of, principal, action, resource, context. I really wanted to break apart like actions and resources. But maybe you could talk a little bit about um, why you felt it was necessary to also define a spec about resources, what you think the state of that is, and maybe just talk a little bit about the design.
Sure. So that is called AAuth rich resource requests, which then had a nice acronym R3. And so in R3, that's still very much an exploratory specification. But in the world of agents, right, if you have, right, there's a number of standardized ways to describe a resource and the actions on them, right? So Open API, MCP provides tools, GraphQL, right? There's about, I don't know, 7, 8 of those. And in the earlier days of agents, you needed MCP and you needed the metadata, the context of a tool for an agent to know how to call it. I don't know that that's true the same way anymore, that an agent could just call, something only described by Open API, an Open API spec. And so in the resource metadata, it says, here's the different vocabularies I speak, and here's the URL to go and get that, the metadata about it, right? So you can say, oh, I support resources that use Open API, and it can go and get those specs. And then the agent could look at those specs and say, okay, here's the API calls, here's a parameter, here's the operations I could do on those. And then it could say, here's the things that I would like to do to the resource. And the resource can then put together a resource document. And then similar to, I think, how UMA works, the resource document doesn't actually go to the agent. The agent gets a URI with a hash of the document that goes to the person server, and then the person server fetches that URI directly from the resource or from wherever the URI is to understand the request. And then in that enables you to have not be limited to what scopes could do in OAuth, but to have a much richer way of describing what's needed in a call. And in it, we also have that the resource can say, here's a bunch of irreversible things that might happen if somebody calls this or not. So that then that can be part of the context that's being made at the person server within the context of the mission, right? So if I let the agent go and do, if one of the things it says, I want to be able to delete a database table, right? The resource can say, that's going to have a whole bunch of bad implications, and have a description of that in text, markdown, that then can be available at the person server to make a decision around deciding whether or not that can happen. Which brings up another feature of AAuth, which is that unlike in other protocols where the agent says, can I do this? And you say yes or no, or maybe what you'd say, well, you want these 5 things, but I'm only going to give you these 4. AAuth has a model of being able to have a conversation. And so not only does the agent say, here's what I want, but it can include a justification of it saying why it wants it, which is particularly important as you get downstream in a mission about like, well, why did you invite this? Why are you asking for this, right? And so the agent can provide the justification. But the user on the other side can say, well, they can send a clarification back to the agent and say, well, why do you need this? Maybe you could do it this way. Maybe you can do it another way, right? Maybe you should, that looks complicated. I don't like using Flying United. I want to fly, Alaskan Airlines. And you can have a dialogue then between the person server and the agent with the user around the permission. So the agent could either provide more clarification for you to rationalize it, or the agent could say, oh, okay, I'm going to go ask for something different because now I understand that maybe the thing I asked for isn't really what I need to do. I want to do something different. And that maps to how, if you've been coding with Cloudering, like how we're actually interacting with agents. And so AAuth provides this whole richer enablement of being able to have a dialogue between the agent and the user and person, or the person and the person server.
Well, we could probably talk about this for another hour or so, which is good because I'm guessing you might do a session on this at IAW.
Yeah, and probably at AIW.
Yeah. So for those of you listening who have the opportunity to attend one of those events, it's coming up pretty soon. The last week of April. I don't know if it's next week or the week after, but it's coming up soon.
Yeah, it's in a week and a half. Yeah, at the Computer History Museum in Mountain View, California.
Right.
America.
And, okay, so I want to get one last question in. I know we're a little over time. My last question, and this is sort of a non sequitur a little bit. What do you think about sort of the future and trajectory of MCP, and how do you see that intersecting with AAuth?
Well, I was looking at MCP and implementing MCP that partly inspired me to work on what became AAuth. It's super powerful, but I wrote a LinkedIn post in the last summer that AAuth wasn't a fit for MCP because as you sort of went and tried to scale it out, you were using dynamic client registration stuff. And so I'm a big fan of MCP as a protocol. It works super well in standard IO within your own framework, but there's big challenges around as you're trying to jump across boundaries. And so many people either use OAuth, but that requires dynamic client registration. So many people fall back to just API keys, which is a whole other huge issue of API keys, and is one of the things where see that AAuth can help solve. Because if you have a agent calling a resource, you can start off instead of going to some service, going to the console, registering, getting an API key, and then giving it to your agent, which then could leak all over the place. You can start off having your agent call the resource, and the resource can allow some actions, and then when it needs to, it can say, I need to interact with the user. Starts off an interaction, user registers, but you're done. There's no API key because the resource already knows who the agent is. And so now you've just you've done some things at the resource for the resource now to enable other functionality at the agent. And that level of AAuth doesn't require a person server, right? It's just an agent and a resource. So it enables you to do some interesting decentralized things because you now have a client identity enabling you to make calls. It enables you to no longer have a API key that can be stolen.
The pigeons are flying, so it's telling me we're running out of time. Let me just give you a chance. I know my questions were all over the place. I guess that's sort of par for the course. Let me give you a chance to share any last thoughts before we call it.
Well, we've gotten a lot of great feedback as we've talked about AAuth with people. It's super interesting how it evolved with agents, helping agents, and how other people's agents helped evolve AAuth itself. And we've turned up a site at AAuth.dev for people to play with it and learn more about it. And it's early days. We're still looking at how do we solve problems. There's probably a number of areas where we've gotten wrong, and keen to get feedback and suggestions about how do we improve it and solve a whole new class of problems that are coming up now that software has changed about how it works, with agent software being very different than how client software worked in the past.
Awesome. Okay. Dick, that was awesome. Thank you so much for coming on. It was great to see you, and looking forward to seeing you, I guess, in a week and a half in Mountain View. So.
Oh, thanks for having me. Always fun, Mike.
And before we go, just another reminder to the audience, please follow Identity Office Hours on LinkedIn or YouTube. IOH is sponsored by glue.org. The next episode, we will have a show on automated reasoning meets AI, the next leap in verified infrastructure. The guest is Varun Pant from Amazon, who's in their, I think, AI development of Cedar tools area. Rohit will also be co-hosting that next week. So on Tuesday, please join us. And with that, I'll say thank you, audience, so much for